we're going to talk about titrations. Can go to the next one. And as we saw in the last class, we did not want to go over because then we will get the wrong values. That's all this is showing. The definition is a known concentration of a base or an acid is slowly added to a solution of an unknown acid to determine its concentration. You're basically trying to determine the concentration of a substance when the number of moles are equal. Next. You have something called the titrant. You can click, and which is what is on top. Titrant with T is on top is the solution that you know what the concentration is. You're going to have an indicator which is going to change color when both concentrations are the same. And then you're going to have the analyte or titrant D, which is down, is the solution of the unknown concentration. When the moles here equals to the moles there, the color will change. That's called the endpoint. Yeah? This is more like the titration we're going to do. One before. At the beginning, we start with all acid, right? So we have a whole bunch of H's in solution. And you have their base over here. In this case, this is the titrant. And you start dropping OHs, and every time an H and an OH meet, they are going to make a water, therefore neutralizing the solution.
Wait, what would the analyte be in this situation?
The analyte in here is hydrochloric acid. It's the acid.
Like the liquid?
Yeah, you have hydrochloric acid in the bottom, so you just have H's, H pluses in solution, right? So these are H pluses. Like hydrochloric acid is HCl. You will also have Cl minuses. We're just not going to draw them because the Cl minuses are spectator ions, so we don't care, right? On the titrant, we have sodium hydroxide. That's the one of choice. All we really care is about the OH minuses, and every time an OH meets with an H, it makes water.
Is the titrant usually a base?
No, it could be the acid, it could be the base. It's the one that you know the concentration of. And the analyte is the one that you're going to analyze the concentration of. It's the one that you don't know. And then again, asking questions is crazy important because if you get this topic, you're done. You don't have to study it again. Once you understand it, that's it. Now, titration terms. We have equivalence point is when the moles of the acid equals the moles of the base, whichever one is the titrant and titrant. And then we also have pH meters. We use pH meters to, if we want to just calculate the pH, we can use a pH meter. But we can also do it with the endpoint. If the indicator changes color. Please do not confuse endpoint with equivalence point. We want them to be close, but they don't have to be the same. That's just another titration. This is for whenever you do the lab. Remember that we wanted the color not to get too strong. Sometimes you have a little drop. Sometimes you have a little tiny drop. And you know that you're very close to the equivalent point because the color has started pulsing, it's changing. And you don't want a big old drop to fall. So what you do is you grab some distilled water and you help this little drop fall. So that's your base, and you help it. And are you going to change the concentration of your analyte by adding water? Yes, you're going to dilute it, right? Everybody okay with that? If you have something with a certain concentration and you add water, it's going to get diluted. However, if you had in the analyte 5 moles of acid and you add water, are you changing the number of moles? No. And since in this experiment all we care is about the number of moles, it's okay to add water to the analyte. Because once the 5 OHs fall, it's still going to change. It's actually something that is done regularly. The number of moles in the flask will not change. The titrant is neutralizing the moles. And I say here, it is common for us to do this as we are trying to get a smaller drop, or just what I was describing, right? In here, anytime that you have an aqueous solution and you are at the equivalence point, you can also use boom boom. Why? because boom boom tells us that the moles of the acid are equals to the moles of the base, and that happens on the equivalence point. So you can use that. If you have a ratio, it may be a good idea for you to remember this formula with the 1/n, because you will be dividing by 2 and you will be dividing by 3. Sometimes we have different ratios, and most of the time so far we have not, but sometimes we can have different coefficients on the acid and the base.
Wait, we can use boom boom just anytime, or
When you are at the
only
equivalence
equivalence?
point,
Okay.
because that's when the moles of the acid are equal to the moles of the base. You can always use stoichiometry, always, and the molar island, but this is one that if you're not thinking, you just want to do it, it's a quick and easy, very way to get it done, just at the equivalence point. Because that's a point in which we care about moles of acids and moles of base. And the 1/2 and 1/3 takes care of crossing the bridge on the molar island. So we're not gonna do this one because we've done a lot of these ones, but if you look at a problem, you have an unknown concentration you have 0.15 milliliters of sodium hydroxide, and you have 20 milliliters of a 2 molar HCl. That will be your known, right? That will be your titrant. This is the 15 milliliters. No, this is your titrant titrant. Because you know the concentration and you know the volume, that will be the other volume. And it doesn't have to be a titration, it can just be any problem. If you use boom boom, you will find whatever is missing, right? So if you are at the equivalence point, you can find the molarity of the acid, the volume of the acid, the molarity of the base, or the volume of the base. This is about talking about indicators. You want to use an indicator that is going to change color right at the equivalence point. So in this case, I could use like bromotamol blue, which changes right at 7, right? It's just not a very good indicator sometimes practically to use. But you want one that is going to change right about when you expect the pH to change. So this is just talking about methyl orange is one indicator that you will use if you expect it. There are a whole bunch of indicators. These are not the only ones. There are a lot of indicators that you can use, but these are some of the most common ones. So we just say we don't want to go over, because then we won't know how many moles we've really dropped. We can go through this one fairly quick. We want to calculate the concentration. Da 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 da. Okay, so can you do this in your head, just to see if we are understanding? You have, this is your equation for sulfuric acid and sodium hydroxide. You have 1 liter, 0.5 molar. How many moles do you have? 0.5 moles, right? So you have 0.5 moles of sulfuric acid, and it's a 1:2 ratio, right? How many moles will it be required? How many moles of sodium hydroxide are required in order to neutralize that completely? 1, right? Does that make sense?
Wait,
So,
can you repeat that?
getting out of the calculator and kind of thinking, you have 0.5 moles of H2SO4, right?
Oh, 0.5, okay.
And for every mole of these, you require 2 of that, right?
Yeah.
So you don't really have to always be thinking, hey, let's use the calculator, this is kind of Greek, right? You can literally think, hey, for every one of these, I require 2 of those. Why? Because you have 2 H's in here, right? So you're gonna need 2 OHs for every, right? It makes sense. So this is what we're doing. It's not too hard, especially when we have a strong acid, a strong base. This is another one that we could have. Again, it's the exact same thing, is the boom boom equation. Now we're gonna go over the hard stuff, the making titration curves, step-by-step explanation. The very first one I'm gonna go quickly because it's a strong acid, a strong base. I hope most of you understood it. So the titrant D is what we have in excess, so we have a whole bunch of acid, and we start adding drop by drop of the base, right? And it's starting to neutralize. This is just a little graph that shows you what happens at the beginning, in the middle, at the equivalence point, right? That's the parts of a titration curve. These are other titration curves that we can have. Next. This is the one that I always do to explain a strong acid, a strong base. When you have hydrochloric acid, which you can buy as off at Home Depot as muriatic acid, and then if you want to use Drano to neutralize it, you can. It's sodium hydroxide. The example that you have in your sheets when we did it, so you can go back and look at that, was 60 milliliters, 0.1 molar, and then we started titrating. So at the beginning, you had, and I started using millimoles just because I've fallen in love with them, but you can use moles. So if you have moles, these many moles of hydrochloric acid and these many moles of sodium hydroxide, that's what we're gonna have. We have 6 moles, and we're gonna be dropping this, and we are gonna draw the whole titration curve. So here we know everything, we're just gonna draw the curve. If you have to, at the first point, calculate the pH of the acid with all you have is the 6 millimoles, and you had, how many, it was 60 milliliters? If you have 60 millimoles and 60 milliliters, how do you calculate the pH of a strong acid? If we have HCl, and it's a certain molarity, it's gonna dissociate 100% into H plus Cl minus, right? 100% is gonna dissociate. So if I have 6 millimoles of this, I'm gonna have 6 millimoles of that and 6 when they break, right? And the molarity of that will be the same. So I just use the regular formula for pH that you know since physical science. Take the negative log and get my initial pH. Everybody okay with that? Yeah, this is the easy part. Then we're gonna calculate it here. We've added 30 milliliters of my base, right? This is the base that you're adding. This is how much you added. Here I have added no base. Here I added half of the base that requires to reach the equivalence point. The equivalence point is when all the acid has been neutralized. This is half the equivalence point, so I dropped half of it. So the limiting reactant is the sodium hydroxide, as I mentioned. Now we do the calculations. 0.1 molar of my acid, this is always gonna be the same, right? Because the acid, what I have in the bottom, I'm always gonna have 60 milliliters of a 0.1 molar in here, right? That's not gonna change. What's gonna change is how much volume do I add. So the first time around I had nothing, and I just got the pH of that, the 0.1 molar acid. The second time around I have dropped half, I've neutralized half of it, right? I dropped 30 milliliters according to the graph of the 0.1 molar solution, so I have 3 millimoles. So I had 6 of the acid and 3 of the base. How many waters did I make? I made 3 waters. How much excess acid do I have? 3 moles of the acid, right? If I want to know the concentration, I had 60 milliliters, I added 30 milliliters. So the new concentration of the excess acid is 3 divided by 90. That's millimole divided by milliliters. The millis cancel, and that's moles per liter. That is your concentration, right, of the acid. Are we okay with that? So that's your concentration of the acid. How do I find the pH? Same formula, the negative log pH. You can see it. It's the negative log of 0.00 1.52. Everybody okay with that? You subtract them to find what you have in excess, But that you have in excess now is over a larger volume. So to find the concentration, you have to use all your volume, negative log of that, and you find your pH at half equivalence point. Everybody okay? Okay, now we're gonna go to the equivalence point. And then we won't have to do any calculations. This is super easy. When you know that you are at the equivalence point, that means that you neutralized everything. Right? So yeah, so all of it became water. All of it is water. I neutralized all my acid. All the H's made OH's. So I had 6, I dropped 6. I need to change that drawing to just 6 instead of 8. It got all neutralized, so what do? The pH will be the pH of what? Water. So no calculations. You know you're at the equivalence point, strong acid, strong base. You had H's plus OH's made water. You had 6, you just made water. No excess, right? So your pH is 7. So that's what this is showing, is 0, no excess is present, just water, pH is 7. Everybody okay with that? Now we're gonna add more. We're gonna add some extra. We're gonna keep dropping more base. Again, always the same titrant, that doesn't change. What we had is the titrant. Now we have 80 milliliters, so that's 8 millimoles. I subtract them. Now which one do you have in excess? OHs, right? So you're not gonna get the pH right away. You're gonna get the POH. So you have 2 millimoles of OH. Please don't make them negative. It's just how we do it. You just subtract them and it's the absolute value of the OHs. Now you have to divide it by the 60 milliliters I had originally, but now I've also dropped 80 milliliters of base. So it has to, the new concentration includes the full 140 milliliters. And that is your OH concentration. I'm not gonna change the color, but it's OH minus concentration. That's your base. You have a choice here. pH problems are really flexible. You can, which is what most people in this class like to do, get the POH and then subtract it from 14. You know what I'm talking about? But you could also say, hey, this is the OH concentration. I just want to get the pH directly. So I'm going to say Kw is equal to the OH minus times the H3O plus minus, or the H plus minus, right? So 1 times 10 to the negative 14. Do you recognize this formula? Is the OH minus, which I just discovered to be 0.014. Times H plus, or H3O plus. I can find my H plus and then get the pH straight. Does that make sense? So if you just want to calculate pH every time, just realize if you have OHs, you can change concentration and get the next one. Everybody okay with that? Yeah? Does it make sense? So you can calculate it however you want to. I'm doing it the way we have mostly done it, but now let's go to the next one. We're not gonna do the second method.